The next video will be the first episode of Story Arc. I need a break from making math class episodes for personal reasons. I don't want to talk about it.
Whoa! Is it true that your video just got copyright claimed?
I don't want to talk about it, okay? Numbers are used for counting, measuring, and labeling. I guess we use numbers in our everyday lives. 1, 2, 3, 4. 34 inches? I'm still fat. Ugh. Yeah. Yep. Numbers have a purpose in mathematics, just like you have a purpose. This video is about the sets of numbers or number systems. And we're going to tell you one at a time and in that order because, yeah. But don't worry, I did an online research on every math class because if it's on the internet, it must be true. Let's start with the numbers that came from nature. Wait, is that why they were called natural or it's just a joke? Natural numbers are numbers used for counting and ordering. For example, 1, 2, 3, 4. Okay, enough with the exercise video. Everyone knows that's not entirely true. Natural numbers are called counting numbers or whole numbers, but counting numbers are not whole numbers. This makes me confused because counting numbers were 1, 2, 3, and so on, while whole numbers were 0, 1, 2, 3, and so on. In other words, the number 0 is the problem.
Why? Is it because you have 0 friends?
Okay, first of all, some mathematicians said that the natural number should start with 1 for traditional reasons, but other mathematicians, especially set theorists, said that the natural number should start with 0 for the cardinality of an empty set is 0. And second, I have lots of friends, okay? I found lots of ways for me to have a friend. Or friends.
Yeah, like what?
I can think of few. Meet new people, talk to yourself, or create your own imaginary friends even when you're an adult. Anyway, to avoid ambiguity whether 0 is a natural number or not, a subscript is used for natural numbers that starts with 1 and that starts with 0. We have 0, 1, and the rest of the natural numbers. As you can see, from 0, the number line goes this way. See the arrow? How about going to the opposite way? Negative numbers are numbers less than 0. Everyday uses of negative numbers include colder temperatures, your bank account, or losing someone you love. Positive numbers are numbers greater than 0. Negative numbers, 0, and positive numbers are included in our next set of numbers, integers. Integers came from the Latin word integer, which means whole. Just think of a whole number with nothing or a minus sign on its left side. That is an integer. Ooh, fun fact! Did you know that the German word for numbers is Zahlen? You don't care? Then why do I have to tell you about this?
Yeah, why do you even have to tell that to us?
Hold up, let me fix this. Got to erase this on my script. There. So, what are the numbers between two consecutive integers? I mean, what are the numbers between 0 and 1? Or 3 and 4? Well, two possible answers. Either it's rational or irrational. Let's talk about rational numbers first. Rational numbers can be expressed as quotient of two integers, or the result when an integer is divided by another integer. They can be represented by a common fraction, mixed number, decimal, or any other representation that Wikipedia said, but I don't know what they are useful at. For example, a fourth sheet of paper, 2.5 men. Yeah. One more thing about rational numbers is that you can't divide any number by 0.
Wait, what? Why?
I can answer that. Let's say JC have 30 cookies. How would he split 30 cookies on 0 friends? It doesn't make any sense. Because how would JC split 30 cookies to his friends if he doesn't have
integers are rational numbers because each integer can be expressed as integer divided by 1, or just any integer divided by another integer as long as the quotient is the same. The decimal form of rational numbers can be terminating or repeating. If a decimal number is terminating or repeating, then the number is a rational number. But if the decimal number is neither terminating nor repeating, then that is the irrational number. Irrational numbers cannot be expressed as quotient of two integers. Irrational numbers do not terminate nor repeat, just an endless random digit that do not repeat. Some of the examples are pi and e, and some irrational numbers are roots of non-negative numbers. Square root of 2, square root of 3, but not square root of 4 because square root of 4 is 2, which is a rational number. I guess that's enough for irrational numbers. Rational and irrational numbers are included to another set of numbers called real numbers. This number line was actually called the real number line. Natural numbers, integers, rational and irrational numbers are found in this one-dimensional object, and real numbers are one-dimensional numbers. The next is about the two-dimensional numbers, or the extension of real numbers. But let's take a break because we have an intermission number.
Wait, are you going to sing again?
Actually, I was thinking of dancing this time. And you're dancing with us, even if it's against your will.
We already know that there is such thing as square root of positive numbers and square root of 0. But what about square root of negative numbers? Well, square root of negative 1 is I.
It makes sense because square root of negative 1 is imaginary and you are just my imaginary friend. It's an existentialist joke.
Get out.
Okay.
I is an imaginary unit where I squared or I times I is negative 1. Imaginary number is just any real number multiplied by an imaginary unit I. 3i, 8i over 3, I squared of 2. Every number that is not in the real number line is an imaginary number. Except 0, because 0 is considered to be both real and imaginary. A combination of a real number and an imaginary number like 3 plus 4i or 2 over 3 minus I squared of 5 is called a complex number. It's in the form a plus bi, where a and b are real numbers, while I is an imaginary unit in which, again, I squared is negative 1. Complex numbers are used in electricity, electromagnetism, spectrum analysis, fluid dynamics, and other scientific whatsoever that you don't want to hear it because you'll forget them anyway. If there's a real line, then there's also an imaginary line. An imaginary line is placed perpendicular to the real number line at 0, turning from one-dimensional to two-dimensional. This is called the complex plane or Argand diagram. Complex numbers can be interpreted as coordinates or vectors in this complex plane, like 3 plus 4i or 2 over 3 minus I squared of 5. Well, that's enough for complex numbers, right, JC?
Yeah, sorry about that. Red wants to tell you about e to the pi I and multiplication of complex numbers represents 2D rotations and scaling in the complex plane. But we need this video to be as short as possible.
If complex numbers are the extension of real numbers, what are the extension of complex numbers? I think you take over this one. My head hurts after thinking about it.
He's talking about quaternions. When I found out about quaternions, I was like, oh wow, what on earth are quaternions? I don't know anything about quaternions, Is it because this is a master's degree thing, doctor's degree thing, other science field thing, or don't have time to teach that to us because the semester is too short to learn everything the book says? I don't know. I just graduated with a degree of Bachelor of Science in Mechanical Engineering and I learned nothing about the magic of friendship. Before we learn about Quaternions, how about a little story time? Right, Jeremy?
Yeah, sure. Once upon a time, somewhere in Ireland, there was a guy named William Rowan Hamilton. Hamilton thought that if complex numbers can be interpreted as coordinates in 2D, then there's also a set of numbers that can be interpreted as coordinates in 3D, which are triples of numbers. Addition and subtraction of these numbers were easy for Hamilton, but multiplication and division are the problem.
Just multiply them like this. What's the problem?
Yeah, it involves a lot of complicated mathematical things to explain that, but keep on reading.
But on October 16, 1843, when Hamilton and his wife walked along and came up to Broom Bridge, he realized that it's not three-dimensional numbers but four-dimensional numbers instead. He carved this formula into the stone, but the carving is gone now, so here's a plaque for evidence. History goes on until 20th century, where quaternions were used to describe 3D rotations. For this reason, quaternions are now used in computer graphics, robotics, or the smartphone that goes boop, boop. Anything that involves 3D orientations, quaternions are used. The end.
Quaternions are a number system that extends the complex numbers. It is in the form a plus bi plus cj plus dk, where a, b, c, and d are real numbers, and I, j, and k are quaternion units. And also, I squared equals j squared equals k squared equals ijk equals -1. Based on the complex plane, each of the three imaginary number lines are perpendicular to the real number line, and the three imaginary number lines are perpendicular to each other. And it's hard to imagine what a four-dimensional object looks like. What quaternions made different from other numbers is that I times j is not the same as j times I. It's because, since multiplication and division of quaternions has something to do with 3D rotations, order matters. A turn to this side and then to that side is different from turning to that side then to this side.
Thanks, Kate. When I'm trying to study about quaternions, it really hurts my head because I still don't understand why do we need four-dimensional numbers to represent 3D orientations. Also, I want to include the scalar part and the vector part of quaternions, but that's enough quaternions for today. I also found out that there is such thing as octonions, sedenions, and 32 eons or trigintaduonions. But those are not important, might hurt our brains even more, and could waste the next 20 minutes of our lives just studying those numbers for nothing. And that's the end of the video.
Wait, what's the conclusion?
Well, Red, the conclusion is this. I still have things to do.